Thank you, Takira team. So good day, everyone. I'm Chun. Today we discuss performance testing via simulation. So just now we heard a lot about other speakers talking shift left testing, shift left. As highlighted in Sparsh session, we know that the test environment is not the same as the real world. So in this session, we will use something very cool called discrete event simulation to do shift left testing for our cloud environment, to find out the architectural flaws before we even set up the cloud environment. So this is very important, especially in the current AI environment. So let's talk about the cloud first. So in the cloud, hardware is not static, right? So for example, if you are using Amazon RDS T3 or T4G burstable instances, your database actually behave differently at different timing because it changes based on the usage. So this is a nightmare for QA like us. How can we trust our performance tests when the environment itself is a moving target? So let's talk about why burstable instances have this QA issue. But before that, we need to understand the CPU credit system that they are using. This is the engine of the problem. So when the CPU credits are high, the performance is fast. When they hit zero, the database will not be throttled because RDS on AWS, the burstable instance has the unlimited mode turned on by default. So this forces the database performance as usual stay unchanged, but AWS is secretly charging you more money for the surplus of the CPU credit. Okay, so this leads to a very dangerous consequence. What is it? We call it false confidence, because your test environment looks good, your test pass, but you are actually shipping financial defects to the production. You pass the QA test, but you are failing the business budget. So let's look at a simplified architecture for our problem here, which I will use the demo these issues. So we have two main players here. First, the attacker. So we use Grafana Labs K6 to simulate high concurrency traffic hitting our API. Then second, we have the victim, which is an Amazon RDS burstable instance. So what most of us do today is called the physical load testing. We simply launch our K6 as our test runner to simulate the realistic traffic. We follow a standard cycle like shown here. We warm up the system, we hit it with a high load, then we cool it down. So this is an industry standard for the load testing. It's what we are supposed to do fundamentally, but it is a slow process that costs too much time and money. So why is it so? Okay, so this slide highlights why is the traditional way failing us? So the physical load testing, like with K6, fail us for these three reasons. First, it's too slow. So if you want to test a 24-hour traffic cycle, well, it takes 24 hours. Normally, we don't have that kind of time to just sit in front of a computer and see for 24 hours. Second, it's too late. We find the issues after we have already built our environment and spent the budget. And third, the cost risk. So AWS Unlimited Mode actually hides our performance failure by silently increasing our bill. So as I said just now, the QA test pass, but the business losses. We need a smarter way. We need to stop testing hardware and start modeling logic. So we create a digital twin for this case. Look at this diagram. So we have the K6 generator, the database connection pool, and the RDS instance. But most importantly, look at the right side. We model the AWS token bucket algorithm in code. We simulate their CPU credit balance using discrete event simulation, or we call it DES. So unlike a continuous simulation that runs in real time, discrete event simulations, it jumps from one discrete event to the next using a future event list. So you can think of DES like a movie. Like you watch a movie show, we only watch the events that matter, the hero arriving, the fight, and the ending. So we skip the parts where people go to sleep, go to the toilet, or have a nice breakfast because they are not important. So discrete event simulation is exactly the same. We use a future event list to jump between important state changes. So in our case, it's like the new request arriving to our API, a CPU credit being spent. So this allows us to actually shorten the time, predict a 24-hour crash in just a few seconds. I will do a short demo about this later. So we skip the empty space in between and focus on the key events. This is why we can find the architectural failures that would normally take a day to discover in lesser time. So if you would like to see the engine behind this, you actually can scan this QR code, which leads to the SNA code on my GitHub. It's a lightweight open source library for discrete event simulation that I built over weekends. So maybe I try, it's a YouTube, it's a very fast one. Let me do, so what you can see here, I launched the demo. This demo code is on the GitHub, so if you scan QR code just now, you can get it. So what I do is I simulate a 720 seconds of the AWS RDS T3 behavior. Look at how fast it actually get simulated. It's building with .NET 10. This one not counted. So 720 seconds, done. Okay, within 16 seconds, it predicted. And what's the output? You can see over here. By the way, I didn't edit this video. It's normal speed. I didn't speed up. So the duration.
See the video. Sorry. We see blank screen.
Never mind. You all can go and see the slide later. So I think there's an issue, technical issue. Yeah, this is a link. But actually, yeah, it's very fast. But actually, if you see the video, also very fast. So yeah, what I show in the video just now actually is this three graph. So within 16 seconds is already show the 720 seconds of simulation of the AWS RDS T3. So after running the simulation, look at these three graphs. So in the standard mode, on the top right, the blue line shows the credit hitting 0, the latency spikes, and the system fail. Okay, so you know you have a problem. But look at the unlimited mode offered by AWS. The latency actually stay flat, below 500 ms. It looks perfect, but it's what we call a silent failure. Your users are happy, but your company is paying more money for the spike. So without simulation, you would never see this economy track until the month-end bill arrives. So in summary, we are moving from reactive to predictive. Okay. First, speed. As I showed just now, we can simulate 24 hours of traffic in just a few seconds. Even the demo cannot show because too fast. Then second, the coverage. We can test edge cases, right? Running out of traffic, running out of credits without waiting hours for it to happen. Imagine you sit in front of your laptop and wait for the CPU credit to run 0. It's very long time. So with simulation, you can do very fast for the edge case. Then third is shift left. So we validate the architecture even before we set up and pay for the infrastructure. So this is a smart way to work, and it protects both the budget and the team. Okay, next slide is my final slide. Okay, we cover a lot today, from the physical load testing to the discrete event simulation. So if you are interested and you are working on high performance system, or if you want to know more about my library that I built over weekend, let's talk. You can scan the QR code here to connect with me on LinkedIn. Thank you so much, and sorry for the small technical issue just now, but thank you for Takila team, and thanks for your time. See you.